Hello, Namaste Bharat, and hello world. Very warm welcome to you. Thank you very much for taking the time this morning to join and discuss on Unix-style composable operations in C. No, we are all good users of our Unix systems. We debug problems, check things in files, and based on that, we are able to pipe operations and do a lot of good things. And you don't have to tell anybody what's happening. If you see the command, you know exactly what's happening. Uh, but if you see a C++ code, it might not quite match that level of clear expressivity. Okay. I know the Unix commands have some weird ways of saying, searching, regex, and all, but that's all the, I guess, unnecessary complexity of the work that is being done. And piping this operation is very so clean that I would love to have it in C++. And as we all know, in the C++ world, we are getting more and more functional, and this composability of things is really something that we as community and I personally strive for. And it gives us a number of good things for free when you do that. So let's today explore how we could write in C++ code uh, something that very much resembles the Unix commands, where you can be very dynamic about it. You can change and move around blocks. I mean, you could sort first and grep later, or you could grep first and sort later, and it is all composable, depending only on the inputs, pure functions. So some very good reasons to use that kind of an interface. Let's see what it is. I should. I have enabled my laser pointer. Okay. So I'm an architect at Expo. I won't bore you with all that. I think I was very flattered when I was introduced. So we are hiring. We are a telecom product company, and at the foothills of new things and very disruptive things like 5G, getting cloud in telecom because it's very intensive, and so it has its own problems and demands. And uh, basically, the love for performance is addressed when you work in the telecom sector. So if you are a C++ junkie or whatever, if you're interested, get in touch, please. So what does a Unix chain of commands piped into each other look like? We have a very simple, silly case here where we have colors in a file and we are going through a set of steps. Can somebody tell me? Okay, yeah. So I'm not seeing on both my displays. I'm not seeing the window, the Teams window. So I won't know if you're raising your hand. So just please, I guess you can just unmute and interrupt me where you want to ask something. And it's very important that you get slide number X to because I'm building up on the same knowledge. And so to understand slide number X plus N, please, if you have any questions on slide X, please ask there and there. So I
Uh,
think,
I
yeah,
believe the page slide numbers are not visible.
yeah, I have not put slide numbers. I apologize for that. And I don't think I'll be doing that on the fly. Sorry.
Yeah.
So, okay. So, no points for guessing, but this is an example of how easily you can compose things on the Unix command line. You are sorting all the contents of the file colors.txt, then getting them to be unique. So you eliminate, getting a unique count on each. So you eliminate duplicates, but you get a count of how much, how many times a text occurred, a color occurred. and then you reverse sort it and you print the top three entries. So that's giving you the top three colors, most frequent colors in that file. And that's uh, such a simple and quick way of doing it. And it's so straightforward. Okay? That's exactly what I would like to have in example or in this talk. Okay. So before we get to the C++ part of it, just uh, some pointers. We are talking about ways to realize chaining of operations. Okay, just like in a command, and we want to be generic. That's our target. We don't want to write a new chain every time. It should be easy to do new chains once you build something. We need to be able to error handle. We need some customization sometimes, uh, and we'll see what it means. And we need flexible and clean ways of code. That's the target, where there is no clutter and there is no lot of boilerplate. We are implementing a boilerplate here, but we want to implement it here once and not turn back to implement it another time. In this talk, I will definitely touch upon some functional aspects and monad. I don't know, I'm not very seriously and technically read about all of these, but I've picked this up over the years. Ranges from C++20, concept from C++20 will be used, but they are not necessary. As you see, we would be by the end of this talk be able to create something that will work, that can work even for C++11. It depends on what operations you need or how focused you want it to be. So we stay on chaining the operations. Everything else is not the core focus here, but if you have a question or query, like you don't know about ranges, please ask. And of course, we'll be seeing some not so good parts. So it's slideware and I'm making a point. So please don't pick up the not so good parts and implement them. Okay. So now if we come back to the top three colors uh, code in C++, what would it look like? Okay. So output the top three colors from there. Let's use our standard library and implement. What would it look like? And I wouldn't be proud of this code if I have to compete against the Unix command line on this. So as you see here, I'll quickly just present. The idea is to pick the colors in this file, but I've used the C in here because I was running on it on a web on Godbolt on Compiler Explorer online. So I just needed to give some inputs myself. So, but I could use this in colors here instead of C in, and it would just be the same. So let's dive into it. It might not be, it doesn't correspond 1:1 with the way the Unix command line works. Of course, you have to use the specifics and the good parts of your platform and your language and your framework. So here we have an iterator going through all the input string, okay, from begin to end. So this is the end iterator, this is the begin. And what do we want to do with those? We have captured a map of counts and we are just adding the counts, keeping track of the colors and how frequently they came. Now we want to reverse sort it, as you know. So the map would have the entries in a certain sorted order, but the map is against a string, FYI. Okay. So, but we want to now sort it based on the value, not the key, but the value, the int. So then we create a vector where we swap the int and the color. And here, so on top of the slides, I have C++11, 17, 20, 14 mentioned. It means this code is possible in C++11 or C++17. The reason both are here is just because I have used for convenience this way of unpacking a pair. Pair has two things. As we know here, we have a string, which is the color, and an int, which is the count. And that's exactly what I have picked here. I have not done pair dot first. I could do that, and that will be still C++11. So nothing, none of the important pieces here are needing C++17, so I put both. But if you go and compile this code, it will only work on this link, it will work on 17 because of this line. Okay, so we just swap the members and create a new vector called as frequency. Then we are interested in the top three only. So if the size of the vector is more than 3, we partial sort the first 3 items. So the entire vector's top 3 items are at the head. Okay, and obviously we want to use greater and not less than. And then we just print them. So here I am not unpacked, as you see. I'm using p dot first and second. So, so this is with this you will get the same output. If you go to that link on Godboard on Compiler Explorer, you will see that it is giving the same output. But as you see, these things do not compose well. You need these temporary data structures in the middle, which is all a waste of space and memory. And you have to do all the steps one by one. Okay, many intermediate steps. Okay, now just because I got this program online on the Microsoft Ranges page, I'm just moving to this problem, which is doing something very similar. Okay, so this was the same operation that we did on the Unix command line in C++. Now, if we see a similar one, let's get the squares of all the numbers divisible by 3. Okay, so we have a vector of 1 to 10, and we have to have our intermediate outputs. Again, we are using all standard algorithms, and you copy conditionally if you are divisible by 3, the numbers that are divisible by 3 from input into intermediate. Now on the intermediate, you go from beginning to end and you start squaring them. Okay, and then you have the output. So this is the way in 2-3 steps and 2-3 iterations of the input, you would get the desired output. Now C++20 brought a significant improvement in how we do this. And I love it more because it is lazy also. And if you don't know what it means, you can go back and refer. But C++ ranges are lazy. They don't evaluate right there where you write them. You have to iterate over them. So we'll see that. So as you see here, the input is the same. We just move the two functions, getting the divisible by 3 and the square into lambdas. And now we are passing them to ranges facilities, ranges functions, where the ranges has a function called as filter, has a facility called as filter, where we say filter all those divisible by 3. So only if your number is, if the input is divisible by 3, those numbers will go through to the next in the chain. Okay, so we see this is already there out there since C++20. Okay, and then you want to transform whatever number you got, you want to make it a square. So, and then finally you go through this pipeline. So this has just created a pipeline and plumbing. It has just, this is the lazy part. You created the definition of how you want to go through the values, and now you actually go through them in the loop. Okay, clear? So this will just print the squares of all those numbers which are divisible by 3 only. All right, so ranges are impressively expressive. See how compact in just one line it is able to do all that we had that previous slide for. And it's pretty declarative. It has declared what it is doing, and then it does what it does. Clean and straightforward. It is extendable. You can pipe more to it and convey the intent very clearly. And obviously, it is efficient. You take one value and go all the way till the end. Then you take the next value from input and go all the way till the end. It may be dropped in the middle because it is not divisible by 3, but that's perfect. So you deal with the values one by one all the way till the end, as against the algorithm approach where you deal with the containers one by one. Okay. Okay, clear so far? So we always had the containers in C++98. Lambdas were used in the examples from C++11, and now we have the ranges from C++20. But this gives me a thought. When this is so good, what if I can use this kind of a functionality when I'm not working on ranges or on containers? Okay, can my core application logic not be so clear? And we do these things step by step, stage by stage. You have onion layers peeling one by one, and then you get to the meat of your business logic, of your core application logic. Can we not do this? And obviously, that's where this stuff comes in. That's how I did it. Your critique and thoughts are very welcome. So let's see a typical case. I want to connect to an external queue where I'll be able to subscribe for some messages. Okay, it's a very common scenario that you have to connect to something and receive messages. Okay, so application connects. You have the creation of a connection as a multi-step process. You have to start up with some configuration in file, where to connect, what is the concern that you're connecting for, dynamically instantiate a client, connect to it, and subscribe to events. Okay, this is what we are seeing in a typical connect. What would the code for this look like? And we are at C++11 land here. So we pick from the environment. So I was saying configuration. So pick from the environment, where is my config file? Okay, if you don't get it, you have an error. Then if you have the variable correct, you pick the contents of the file because you have the file name now. If the contents didn't work, throw. Maybe you want to stop. File IO error, something happened. Then you make the client, and if the client was correctly instantiated, you want to apply the config, you want to connect, and now you want to subscribe to your events from the queue. Okay. And if something goes wrong while all of this initialization process is ready, at the end of this, your client would be ready to receive events for what it wants to subscribe to. And but if you don't go, if something doesn't go well, you have an error. And all of this error handling is coming in the way of how you see code. Do you see where are the important steps? It's difficult to spot. I've removed all the error handling, but if you put all of that there, this would be like scrolling and it would not be fit for presentation. So that's what a clumsy world looks like, a reality for many of us, and even for me. So I wanted to do better, and that's where I wanted it to be okay. My animation just messed up a little. I wanted it to be very clear and just like Unix. And that's where I would say, on a drum roll, can we have something like this instead of what we had on the previous slide? This would be where I would like to be. Very clear. It exactly tells you what it does. Okay, and this is C++7. We can do this all in C++7. We don't need C++20. Right. Next. How? Obviously is a question. So let's start simple. And let's say we have some function to get the file content. So we are looking at just the first leg. I'm going to the previous slide. So we get from the environment a variable file name. And with the file name, we get the contents of the file. Let's just check the first step. And we have a function to exactly do that, get the contents of the file, whatever the code may look like. And this is what you do. In C++, we have operator overloading. And what is a pipe? Pipe is nothing but a bitwise OR operator traditionally in C++. So if you have your own types, and if you don't, if you're not working on your int types on the regular types, then maybe sorry, I didn't mean regular. I meant default data types, the primitive data types, where they are implemented in the compiler and in the language. They are specified. But if you want to extend it to your own constructs, that is exactly what you do. So if we look at the first step, we have a string from the environment variable, which is the name of the file, and we have the file contents. Sorry, we have a function to get the file content. Okay, and that's what your operator will look like. You can connect any two things, and in this case, we have string on the left-hand side and a function on the right-hand side. And with this, now such a code is possible. You get from the environment the string, and you pass it to file content, and you get the contents. The resulting expression here would be an evaluation of the OR operator. The first one is getting the string. The second one is a function, so it will be invoked here like this. Clear? This is what we are going to build on. And if if you get nothing else from this entire presentation, that code block in the middle is uh, is the core idea. Don't do it this way. It's the core idea. I'll go ahead. Please interrupt if you have any questions. Just let me know. Okay, but as you know, in C++, a function is not the only callable thing. You have lambdas, you have classes with operators overloaded, the function operator, function call operator overloaded, and you have function pointers and many other things which you would like to just be able to use. And that's where we want to make it generic, okay? Because C++ has many callables. So let's introduce. So if you see from the previous slide here, the T was a string, okay? And this was a function pointer, okay? So I've just made, because we are talking generic now, I just made the type as T, anything that you want, and I'm taking that T and I'm using the T, okay? And the second parameter is a callable, and that's what I'm receiving here as fn. It can be anything. Now, this is how you do forwarding in C++. If you're not clear about it, we have to make sure that the R value ness or L value ness of objects is maintained, and that's how we ensure it in C++ as of now, unless something like a forwarding directive comes up. Forward directive comes up, like this has been voted in for C++ 23. So we take two things, just like before, a string and a function. It could be anything, something and a callable. Okay, and on purpose, I'm using so I don't know what the return type of this operator could be. It will be exactly what the callable will return. So we have the trailing return type here, specifying for the callable, whatever the result is, that will be returned, and that's how you say it. The result of callable T is the type of is the return type of this function, of this operator also. And since this could be any callable, you have to forward it with the right semantics, L value or R value. So you just call std forward of the callable fn and invoke it with the std forward of T. Okay, if we were in C++ 17 land, we would write std invoke here. And so despite making it generic, we are still able to write the similar code. And this time we are able to support a lambda. Okay, so we have the lambda taking a function, a file name, string, and giving you the contents back. And you still have this code working. Okay, we go ahead. Sometimes, as we saw in our example, sometimes you want to call a member function on the object that you're working. So you have a T from the left-hand side of the pipe, and you want to call a member function on it. And how could you do that? Well, there are some options. You could actually implement a free function instead. So instead of writing client.connect, it might be a good idea to make it connect free function, which takes a client. Okay, and this is where all this composition and it is also enabled. All the composition is enabled if you have free functions, and you can mix match them in any order anywhere. So we can have a connect function which is independent of the type, and it takes the type and does the connect bit on it, exactly what the member function would have done. Or if that's not possible, you can write a wrapper. Now this is a connect function, okay, free function, which takes a client and it calls the member function. So it becomes absolutely equivalent. And we know that in C++, if you compile with any level of optimization, this wrapper will just go away. It just becomes a user's convenience, and there is no penalty of two calls here, right? Or maybe you could use a standard library if that's what you want. If it is suitable for further chaining, for example, the return of this connect was exactly what you wanted. If the member function did not return, in case the member function did not return exactly what you wanted to pass down to the next function, then this may not be an option. If that's exactly what you need to pass down to the next level in the chain, perfect, just use the standard facility. Okay, and so if you have a make client, which is creating a new client, you can just have a mem function called on it by using this standard facility. So you have these three options I have noted here. This one could be a lambda also, and there could be more options. We are in C++, of course. So that's what you do to make that you are able to call member functions also. Okay, so we have built up starting with one value, how to call a function pointer or any callable, and now in any callable we are able to include member function also, and this will still work with the same operator that we defined on the previous slide, the generic operator. Okay, so to chain operations, callables have to take what the previous step gives. Hang on, am I at the right slide? Okay. Okay, yeah. So to chain operations, your next step should expect what the previous step is giving as output. And obviously it should give as output what the next step needs. Okay, and if that's not the case inherently in the functionality that you are using, you might have to do some wrapping business or something else. One more reason to have wrappers or something like that, wrappers is in case of error handling. So what happens, for example, right now, if something like connect fails, which is the fourth step, and you want to know, in the original code, you will remember every step had an L. Every step had an L. It was so verbose, but you knew exactly where it was going wrong, and you might want to solve your problem, of course, if you have any. So how do you know in this case that there is an error? So that brings us to the next point, which is about errors and cleaning up. Now, there are two problems there. One is a possible memory leak if you just error out. For example, we talked about of a new client being created and then it being connected. In that case, if your connect exited and didn't do the cleanup, it would be a memory leak, right? And we shouldn't have connect actually do the memory cleanup. It's not the connect job, right? So what do we do instead? We use standard facility. So from make, we have the make unique to create any instance. So if you make unique a client, you get a unique pointer, and you make sure that your wrapper accepts the unique pointer and works on that. In this case, if your connect went well, you return back the unique pointer so that the next stage can continue to work on this client. I'm sorry about the typo. This should be client and not C. So I'll correct it in the slides before publishing. So you try connect, and if it did not work, if it did work, you just pass on the client so that the next step can happen on the client. You are building up on the client, functionality by functionality, step by step. But if you didn't, you could just throw. And here it is guaranteed that this unique pointer will make sure that all leaks are addressed. So we are clean. There is no issue here. So there are two things here. One is that throw is the way to report an error because you don't have the return type of your favorite or people's favorite bool. might not be your favorite. If it is not, it's better. But whatever your testing, your error strategy is, you have to stick to it. So if you couldn't return a bool, or if you couldn't return one of an error condition, what would you do instead? You would just throw. And if you throw, everything stops at that level of the pipeline. So all that is clean. And if you have managed pointers, your memory is not leaking, and you have reported the error. And you should make sure that the exception that you raise is exactly revealing what the problem was that happened. If everybody just raises a standard exception which doesn't tell you exactly what happened, uh, it might not be helpful to know which part of the chain actually failed. Okay, so now if we come here, we can, if you want, uh, wrap it around a try and catch specific exceptions where EX1 tells you exactly that making a client failed, EX2 tells you that connect failed, EX3 says that subscribe failed, or one for every step. Maybe environment didn't have the variable. So it helps you build up and exactly track what went wrong. And it is so clean that all the error handling is moved aside, and it's your worry only when something goes wrong. But normally when you're reading code and you're seeing what is this functionality doing, it's all in one place. That's the good thing about exceptions. It's not coming in the way of clear intent in the code, and the core application logic is very evident, as you just see. Okay, and with this, I'm almost hypnotized. So this, with this, we complete this uh, look into making sure that, and making sure that the entire chain is implemented with piping as the operator, right? And I'm so glad with it. It is so clear. It shows the intent that I see it everywhere now. Everywhere where there is change things, there are step-by-step things. I now want to use uh, the same operator. So I want to do this. Receive message is a function. So you are listening for a new message. You're waiting. You're blocked. This could be your core application logic if you are a network IO waiting for a message, or if you're a web REST HTTP REST API or something. You're just waiting for the next request to come to you. Okay, so you are an RX message. That's your core application logic. Um, you pass the message. If when you receive a message, it would return. This function would return, and it would give you a message. You pass the message, and you get a parsed message as the output. That goes to a validate function, and it validates what you expect in the message. What is it an appropriate message that you need to process? Then you do some extraction from it. Maybe it's a store that you're having. So you could have a store where things are pushed to you, and you just keep on accumulating them. So you extract the thing that you want from the message, and now you are able to store. And at the end of this line, if you just loop back to calling this line again, this is your core application logic. How big do you need it to be? Okay, if you're doing just that one step. Let's look at another message. A scenario which I came across recently also. Oh, yeah. So this is where you are a through, what do you say, pass through. Okay, you receive something from the left, you send something on the right, and optionally or potentially you could enrich something in the middle. Okay, so I've come across this IoT scenario recently, where you get some messages and you have to publish it on the other side to a cloud or something, or you get something from the cloud and you have to publish it to the IoT device. So what would you do? You block on receiving the message. Once you receive the message, you check that everything is okay with it, with parse and validate. Maybe you take some action. I've maintained the word extract there, but maybe you take some actions. Maybe you have to log the event somewhere. Maybe you have some responsibilities as a part of receiving the message. You do them, You enrich the message with some more data. Maybe you want to make it, you have to add a few things to it, and then you send it to the other side. And you could do this same thing, similar thing with the pipes. Okay, this now for this was all about waiting for somebody else to tell you something, waiting for a mouse click or waiting for a message from the network. But what if you have an internal need to go out and reach out and create a new message, send a new message? So then you have a trigger, some trigger, maybe a timer. Maybe you just loop and continuously do this. It's up to you. So you trigger, and because the trigger is to send some information, you make a message, you encode the message in a network format as the other party would expect. And here we have JSON passed on as a type. So you could have even function templates passed on as instantiated functions. They then become functions, and it would then, because of this pass type of JSON, it knows that it has to encode things in JSON format, and that happens here. If you have to encrypt, now you need some data. So this was a data type. It is a template argument, okay, template parameter, and this is a data type. So you could pass XML here, you could pass photobuf here, and you would encode in that format because it's the type. Okay. But sometimes you need data. Like I need to see the key of a certificate to encrypt my message on the way out. I need to know who the other party is. So that's data. That's a variable that you need, and that you can make sure that you have this way of calling a function, where now this function would take two parameters. Okay, an encrypt function would take two parameters, a message and a certificate, typically. Okay, I'll leave this. I've not shown this to you in the presentation and by writing the code, but I leave this to you as an exercise. We discussed that passing a template argument is just like instantiating a function and passing it. This one, I leave this as an exercise, how you could do it. Two words, lambda and bind, come to my mind. You could use any of those, or a third one if you think of. Please get in touch with me. I would love to know. But you could use any of these facilities to bind a data, to already have a data that you expect to use in this function, which is now going to receive two things now because of this. You have the certificate and the message and a JSON encoded something from the left-hand side. Okay, and then you send it on the other side. So here, again, send, you might want to decide who you send to. So there could be some pass parameter there, but I'm not showing the same thing many times. So these are the two styles that also you can enhance in the way we have done things. Okay, that brings me to a C++23 discussion on something new which is coming next year in C++. Before that, I'll just pause for any questions. Any questions on chat? Okay, I'm not going to go to chat. Okay, I'll go next. So, Sai Brand, a prominent C++ figure from Microsoft, has written a paper, and it got accepted in C++23, and it is adding monadic extension to std optional. So if you know, std optional is a C++17 facility, which 17, I hope. I hope it's not 20. I think it is 17. Yeah, it's 17. And you could have things optionally coming out of your functions. So something that I did not highlight in the way you could do this functional chaining of things is you actually work on value semantics. You are actually returning messages. You are returning client. You are actually working with the instance. It's not by reference. It is not going to have a spooky action at a distance if you do it right. And if you're not, so if you're actually dealing with values as you create them and you handle them all the way till the end, uh, you are in a very sound place that your application will not have side effects. Okay, and that's what one of the benefits is. And so, if in the value world, if your functions which are returned, the objects which are returned from functions, if they are objects, what do you do when you can't do something? For example, some failure is encountered. So what do you return? In that case, we have this optional functionality. I think you may know about it, but I just wanted to put one line on it. So either you have it or you don't, but you still, when you have it, you have an object and not a reference or a pointer. So that's a very good and clean thing to do. And it allows for more functional things like adding the monadic extension. So monads are a functional construct, and they, uh, you would do transformations in a function, you would do chaining of operations, and or else. And if you, based on what we have discussed so far, we are exactly chaining things. And if this is coming in C++23, it is so exciting. Let's look at what it does in C++23. Okay. And many thanks once again to Sai and whoever else are co-authors for getting this done. So these are the two images from the tweet. Okay. So get cute cat is what they want to do. And you start with an image, you crop it to the cat. So you just crop the cat out of the image. Okay. It's a use case that is shown. If you were not able to crop it, maybe you didn't find a cat, you would stop there and return a null operator, null optional. Okay, you add a bow tie to the cat, maybe that fails, maybe it goes ahead. Then you make eye sparkle, you make it smaller, make the image smaller, you add a rainbow, and voila, you have a chained operation. This looks very, you have many things that you're doing one after the other with a possibility of each step failing, and everything is returning an optional, and you are bound to implement it like this today. But when C++23 comes, you could just say to the optional, you could say, and then call this on your value, and then call the next thing on your value. Dot transform it into smaller and dot transform into add rainbow. So this would give you the desired output because the std optional is taking your operation and is able to apply it if there is a value on the value inside it. Okay, so clean, and so I'm so happy to see it. But what I think is, yes, there are some technical reasons why it must be called as transform. It must be, and then it is needed to be this text. And I checked with Sai also, and they said that it has to be and then, and it is not the same as then, because so many languages and std future also has it does not have. There's a proposal going on, so you have then, but that's not what we need here. We are very clear. They were clear that it had to be and then. So I don't know so much about the functional side, but I still think it is too verbose. Okay, and it has the similar kind of effect. We don't know how error handling will work. It's up to the user. No mechanism to which step fails, and need to use all those things which we use in this talk in order to error handle, memory cleanup, blah blah blah. So, but I would imagine, could it not be like this? I would get this cute cat in this way by piping the operation. Does it matter to you that whether it is and then or whether it is transform, whether the function signature is taking a transformation function and it gives you the same thing or a different thing? So to me, it was not an important detail of the implementation to warrant the use of the word transform and then there. Okay? Uh, I'm an engineer. I want to get things done well. Theory might matter, uh, and it might be good technically more correct to say and then perhaps or transform. Pardon me if that is the if that is necessary to you. But what I think is this is what my code looks like. This is what my application is. It doesn't matter that it is a transform. So what could I do? I actually spent some time in solving that, in actually coming up with a possible code which could do it. Okay, and so if I don't think we have, if you have seen the monadic interface of operators, there are three things there. You have something called as and then. Okay, you have a transform, and I think I could switch to a browser and quickly show you. I have the compiler explorer also open here. Oh, did I close it?
Control Shift D.
Yeah. I'm sorry, I should have had this open. Or maybe I have it open somewhere else in another window. So we have this optional with these three monadic operations, okay? And they help you apply. So we'll quickly just see we've seen the example, but I wanted to show the or else. So we have the and then, the transform, and the or else. I guess they just differ in argument. But the or else tells you if you don't have a value, please use the value which this lambda is given. Okay, so it is giving you a new optional, which is what the final return would be. So that's why the or else happens, because you want something in the error path also. If you didn't get something, you could say or else. Okay, so I'm not very sure about or else, but what I've done in my code exploration here was to solve for all the three, I guess. But in case of any issues, please let me know. So we have three cases here for the and then, for transform and or else. But I have one more case here, which is for the T itself. Because as you see, our first item, the image itself, we would love to pipe that into the first function. Okay? If you need that, you need the fourth. So let's look at how it can be achieved. Okay. So here, this is what I did, and I posted these things on the tweet in the tweet response to Cybrand also. I didn't get into any responses, any replies, or discussion. There was a like, but yeah, you're free to check it out. There is a link which I will share in this presentation also, and it's there in the tweet too. So here we have the similar kind of a thing, and here you see C++ 17 invoke is used. Okay, and we have the same two things in the operator T and callable, and we just invoke the callable with the T. Okay, that's all we do here. But what are we calling this again? We have the T and the callable. Okay, here we are just trying to specify that there is a restriction. This is a concept, C++20 concept thing, where it allows you to put some constraints on when this function is applicable. And this is putting a constraint that callable should be invocable with const t or with tref or with the ref. Okay. So I just want callable to be able to handle the t. So as an obligatory check, the compiler at the time of compilation only will make sure that these clauses are fulfilled by the callable. So if your callable is able to be invoked with C, const T, or T tref, this function is then applicable to will be used by the compiler. Okay, so these are so it's a concept. Invocable is a concept. Callable is invocable with T. Okay? So then you're able to invoke. So this is the same thing that we implemented in our previous slide. Okay, just invoke the function with a T. Now we come to optional, and here I'm using another concept which I will introduce to you later, or let me do that. Sorry, I'm moving across the slide. So, so this is how I would define a concept for optional, and I failed to define something here, like how would value or how would I be able to specify a value or. So as you see, it is not a very foolproof kind of thing with respect to this one. But I think these are the essential interfaces of the optional, where it has a value type, and you have the function has value to query whether it has a value or is it blank, because it is optional, so it could be blank. Get the value, you should be able to dereference the value, and you should be able to say value or. So if you don't have the value, give me some other default. Okay. So I was not able to specify that last part, but with this concept defined, my optional would look like has a value optionally, okay, based on these, and it should be constructible from the T that it holds. Okay, so that's what an optional T would look like. Coming back to the and then overload. So all these are overloading based on the intended function. Overloading the operator based on what you want to do here and what kind of callable you are wanting to access. So from the optional, so now we are taking not T but optional. Okay, but the T would pass for optional also. This is the whole reason why we need a concept for optional. If I just had the previous slide, T, the optional of T of something, let's say optional of client, is also a T. And this function would get invoked by passing the entire optional to the function. But we don't want to do that. We want to unwrap the optional and pass the value to our function. And this is the whole reason why this overload on this concept was needed. Okay, I could get specific here perhaps by using std optional that would bind the user to just use optional std optional, and it would not be generic. So if you have boost optional somewhere, this code won't work. The code which uses std optional specifically that data type won't work, but this concept will let you work on that also. So we are targeting generic here. Okay, so quickly, no surprises here. Now this is, since we know that optional has a value type, which is the T that you want to call the function with, you have the optional and callable taken in, and now you want to invoke the optional only if it has value. If it does not, this operator returns a null out, right? And that's what we saw on the web page also. And then takes uses the value or it returns a null out. Okay, so it would so we want to invoke the callable, and we move the value from the optional. Okay, so we move the optional here and take the value out and forward it to the callable. So std invoke fn and std invoke the value of the optional, or else if it does not have a value, then you return a null out. And that's what you need to do to implement and then using the pipe. Similarly for transform, now you want to make optional. Okay, I'm sorry, I think I was wrong in one thing. It returns exactly what the and then would return exactly what the pass function returns. Okay, so its return type is the same as the value of the invoke here, wrapped in an optional. But here we need to make an optional. So okay. So transform gives you back t. So I was saying the wrong thing for, and then for transform will give you back another t because it has taken the t from the previous optional and now it changes something and gives you a t with some changed value or something. So, but then you need to give back an optional. So that is what this would do. And that's what the transform function does, that it gives back an optional from a function which just gives you t. And but you expect an actually optional out. So you make an optional here by invoking. So you invoke the callable with the t by moving the value into your callable by passing the move value. So whatever this returns, you have to make an optional out of it, and that is what the return of this operation would be. Okay, as you see, it specifies that it is the return is the std optional of the value returned here. Okay. Uh, yeah, I think this could have been optional. The data type bound here, it could be opt here, but I've used std optional because I had to run it with std, maybe that's why. So here you instantiate the optional and give to it the t that you got from trans. Okay, and you get the picture now. There is another overload now for or else, where for or else the callable will give you the value in case you don't have a possible value in case you don't have the value inside the option. So the invoking of the callable goes into the else part of whether it has a value or not. If you have the value, you just give it, move it out. If not, you give whatever this callable gives. And there you have it. All of these operations are now possible because of these two concepts and the overload because of the concepts. This was what I ended up saying. It is really good and nice to see that C++23 is concise. And unless I'm missing something grave here in how it can be realized, I've had this code working, by the way. I have a compiler explorer page where I have this working here. It compiles, it results into the same code as you would if you called it. I think it's this one. So here I have the main here, and I'm calling get cute cat here by doing by passing an image, and this function is doing the same thing what we had in the online example, and it works. The program is doing crop cat, add bow tie, eyes smaller, rainbow, exactly what we did here. And this is functional working code. And so by using the operator and an optional concept, we have pipes for the win and clarity for the pride. Yes, there are some things which I mentioned are not handled there. I could handle better things, and maybe cleaner forwarding is something that I've seen in the Circle language. We don't have it in C++ as of now. Let's see what future brings. Somebody was saying something?
I believe that if all your functions like take in stood optional of the type that you expect and return the stood optional of the type you expect, you can just remove the differentiation between and then and transform, and that is one less overload you have to take care of.
Okay. You mean the operators?
Yes. So let's say that the operations that you're chaining, the input of that function is the stored optional of the type you expect, and the
Yes, it
output
is
is
the
the
case.
stored optional of the type you expect. Then you don't need both and then and transform. You can just have
No.
one and that will
So,
work.
so yeah. So that's not how we write code, right? We don't write code for optional keys. We write code to work on keys. And in this case, hello, by the way, we needed it to work on the optional keys. So I guess we could do that, but it's not the best way to do it, right? Thank you, but super point. I actually thought that would be the case, but when I worked on it, I realized it. Okay. So that brings us to the end of uh, the discussions. I would just recap briefly. Get functional, make pure composable functions. You can fit them as you like, split them as you like. Use value semantics, uh, helps you with cleanliness, sureties. This may not be an appropriate approach in every case that you have. Okay, there could be. It's up to you. Creating the right concept may be hard. Like I struggled with the concept for optional. Uh, it may be hard because the way the overload for concepts work, um, I forgot what is the term. The term for uh, resolving the choosing of the from an overload set the right function to call.
Overload resolution.
Sorry,
Overload resolution, I believe.
not overload resolution. The concept has something called as you have to build up one concept on the other, and I'm surprised how I forgot it, but I'll come back to it. So. Uh, because the concepts may not see each other as an increment of each other, and the overload resolution needs to see them to find out the most specific overload of the function that you provide. It may get a little difficult for you to come up with the right concept. This is something that I had tried to cover in my talk in CPP India Con 2021, uh, and so it might be something to watch out for, and understanding the style. Somebody who may not appreciate the details may not be able to get it, but I think everybody gets the pipes code, and that you can just name the functions one after the other, and uh, enjoy your time on the beach, vacationing, I guess. So, but there could be a learning exercise here. But you once you build, the reason we build something generic here is we don't want to build it another time. We build it once and we reap the benefit everywhere. Okay. So with that, I'll not take any more of your time. I would say that there might be some mistakes. If there are, if you come across them, if you know about these things or spot something, please tell me. I don't have time to make all of them. And that's it. Thank you very much. Any questions? I can take.